Okay, here are the rest of the problems. Hopefully you didn't shy away from 18 through 24. Even 25 is a good problem. So just because they're a little bit longer and look a little bit harder, you can't try. You have to try them. All right. So when I look at this, I have y plus 2 already in both of them, but this one needs a y minus 1. So I can tack that on to the end here. Barely fits, and then I need to put that up top also. And then this one has, y minus 1 and y plus 2. It needs a y minus 5. So my bottom has 3 binomials in it. Okay, and then the top becomes, I'm just going to FOIL this out. I have y squared, and if I do the middle part, I'm going to get -1 and -5, so that's -6. Make sure I rewrote this correctly. Alright, -5 plus 2. Alright, yeah, so we FOILed that correct. And then plus 5. And then plus in the middle, y times y is y squared, and plus a -5, so that's just like subtract 5. So we have, looks like we have 2y squared minus 6y, and you put 5 and -5 together and you get 0. So yes, you have to write this again. And number 18. Okay, looks like we can pull out a 2y out of this. Something not quite right here. Yeah. Back up. Maybe you saw this. When I do y times y, I get y squared. Y times -5 is -5y. I knew something wasn't quite right here. Alright, so that's obviously wrong. So let's do this again. We have 2y squared minus 11y plus 5. Alright, so now see that? Alright, so we have to see if this might be factorable, and it might cancel out one of these binomials. So when we do that, we have 2, there's only one way to get 2y squared. So I'm trying to factor the top. Alright, so I need two things that multiply to 10, two numbers that multiply to 10, but add to -11. Well, think about it. -1 times -10 would work. Okay, so if you think about this, I need to have the -5 there, okay, and the -1 there, because when I do my FOIL, I'm going to get -10y and -1y, which is going to be that -11y. Okay, from there you see that this matches up with that. And in the very end, you notice that I have I'm doing this in presentation, but I'm using a whole piece of paper here. Okay, so I have 2y minus 1 over y plus 2 and y minus 1. And it also took me 4 minutes. Alright, so we gotta hurry up, but this one shouldn't be too bad. Alright, what I need, alright, this one already has an x minus 6, and it has an x plus 2. So I need to add an x plus 2 to this one. Alright, by multiplying, top and bottom by that. Now, don't forget this 2. this doesn't match exactly. I need to multiply top and bottom by 2 to make the bottom exact. So now I have 2. Here we go. 5 times x is 5x. 5 times 2 is 10. And this is going to be minus 40. Here we go. So we have 5x minus 30 over the denominator there. Okay, now you may think you're done, but we can factor out of 5. Alright, so think about that. When you factor out of 5, that's going to be 5 times x minus 6. And, you know, the authors of this textbook make sure that something's going to cancel out after you do that. So we end up with, I'm going to write it over here so we can see it. We have 5 over 2x plus 2. And number 20. Alright, can you turn that down, please?
Yeah.
Alright, so when I look at this one, p minus 3, I have that one. But this one has a p plus 3 in it, this one doesn't. So I need to add that to the list. And how do I multiply these two together? Through foiling. You're going to foil the top here. Now this one is missing the p minus 2. So a lot of multiplication going on up top. So I'm going to write that out. That's what I have left on the bottom. Alright, now I have to make sure I FOIL correctly. I have 2p squared. I'm going to have 6p and negative 3p. So that's positive 3p. You're going to have 6p and negative 3p. So 6 minus 3 is the 3p. And then minus 9. And now, think about this. This is subtract this. So when I think about multiplying this, you know, think about it like that. It's subtraction. I get to distribute a negative 5 to both of these. So I get negative 5p plus 10. Alright, so let's collect like terms up top. I have 2p squared minus 2p plus 1. And this is not factorable, so nothing's going to cancel out, and we're done. So look back over that. You know, what I saw the problems yesterday, most people were just not multiplying correct. Alright, up top. So take your time, spread the work out, you know, use the space up. A lot of people are trying to cram everything in one little spot, and you're getting messed up. Alright, so if you think about the common multiple between 5, 4, and 10, think about it. If you do 5 times 4, you get 20, and that's also a multiple of 10. So I think it's pretty clear to see that 20 is your least common multiple between those. So how do I make this 20? I multiply by 4. How do I make this 20? I multiply by 5. How do I make that 20? Multiply by 2. Now, I also need an n. These outer ones have an n in them. This one doesn't. So I need really 20n on the bottom. And multiplying this one by 5n is going to give me 20n there. So really I have 4 over 20n minus 15n over 20n and plus 14 over 20n. So I have common denominator there. I'm going to if I rewrite this, sorry. So 21 because you might think 4 minus, you can't do that, and then plus 14. You might be wondering, well, can I put the 4 and the 14 together? If you write it all in one sentence, of course you can. So that's negative 15n plus 18 over 20n. And you're done. Okay, 22. Again, we're adding or we're subtracting and adding 2 or 3 different things, but it's not too difficult because think about it. This one already has. Now I had to do a little bit of work here. I had to, factor that. But after I factor that, it's pretty simple. Difference of 2 squares. I need to add an a plus 3 here and an a minus 3 here. And now I'm going to have a common denominator, and plus 3, one of their opposite signs, and we kind of run from there. So I'm going to just show all my multiplication in one spot. So 2a times a is 2a squared, 2a times 3 is 6a. Now when I look at this, I'm distributing a negative. You can do that. You can turn it into addition, and so it looks like it's negative. So here we go. That's negative 2a squared plus 6a. And then I have 36 on the top there. I didn't do anything with that one. Alright, so something happens here that hasn't happened before is that I have a positive 2a squared and a negative 2a squared. So those two are opposites. They're going to cancel out. Alright, so what I have is 12a plus 36 over a minus 3, a plus 3. But you can factor out not just 2, not 4, not even 6, but 12. 12 is the biggest factor we can pull out of there. And look what happens. So hopefully you can see that's a little small, but a plus 3 and a plus 3, once you factor out a 12 out of the top, so you end up with this whole mess turned into just 12 over a minus 3. So take a look at that. Alright, 23. I know this looks pretty daunting, but really all this is we're going to add. We have an addition problem, and then we have a division problem. But we have to do the addition first because that's up top. Alright, we got to take care of that. So add like you know how. This one, you might be thinking that all I have to do is switch the sign in the middle, but it's just not going to work out. So you have to multiply this one by x plus y and multiply this one by x minus y. There's really no simple trick around it. So from there, distribute the 2. So this becomes x minus y, x plus y on the bottom. That doesn't change, and I have 2x plus 2y plus, I'm going to distribute a 1 to this, so I just get what it is. And this is still divided by x minus y. Or 1 over x minus y. Alright, then looks like I have 3 x's and 1 y left on top when I collect those. Now remember, to turn this into, how do we divide? We turn it into multiplication and flip. Alright, so Mr. Sagasi was saying to invert it. Alright, so I called it flip. He said invert. Either way, once we're in multiplication mode, now we're in cancellation mode because these two are exactly the same. So if you think about it, hopefully you can see all the way to the bottom, you have 3x plus 1y over x plus y. That's your final answer. So we had to take care of the addition first, and then we turn this in. Then it's a division problem from there. Same exact thing here. All right, another 16-minute video. All right, here we go. We're going to subtract this before we divide. I'm going to make sure I wrote it out exactly right. Okay. Here we go. So, our common denominator, I got to multiply this one by r plus 2. I'm writing kind of small. Minus. So this one already has the r plus 2. All it needs is r. And we're still going to divide what's up there. Alright, so I'm not going to rewrite it a bunch of times. So here we go. R times r is r squared. I have 2r and 6r, that makes 8r, plus the 12, over, well, don't want to forget this, minus 1r, and then over r, so r plus 2. And I don't know what that symbol means, I guess see above. Alright, so there we go. Let's put this together. So we have r squared plus 7r plus 12. I am going to run out of room. Alright, so I'm going to turn this into multiplication. Okay, so I'm going to take this expression, alright, and I'm going to invert it. So r squared plus 2r and r squared plus 4r plus 3. I need another piece of paper. Hold on. Use that. Alright, now it's a little crooked, but alright, so what I could have done, you know, I know this stuff's factorable, so I need to factor it. So that's what we do when we multiply. If we can factor it, we factor it, so it might, you know, simplify. So this one is r plus 3 and r plus 4. And then this one here, top right, is, I can factor out an r, looks like, oops, r plus 2. And then this one looks like it's r plus 3 and r plus 1. So there's actually 3 things you have to factor there. But once you factor them, you see that this r plus 3 and r plus 3 will cancel out. And this is exactly the same. So this r and r cancel out, and this r plus 2 and this r plus 2. So a bunch of stuff cancels out, and we're left with r plus 4 over r plus 1.